In this video, let's discuss dilutions. Now, the dilution equation is commonly known as M1V1 equals M2V2, which you see here. A lot of students see this equation though, and they get so excited because they understand it, and then they try to use it for everything, including reactions, when you convert from moles of a reactant to moles of product. Now, keep this in mind as you're watching this video. That is not meant for that because you're converting from one chemical to another. These dilution equations are when you have one chemical and you're just diluting it. It's sort of as if, I don't know why you would do this, but if you take a drink of sweet tea and you're like, that is way too sweet, and you add water to it, you're diluting it. Now I've done that before, so I can't say you're crazy for diluting it. But that is a dilution. Changing it from one compound to another, that is not a dilution, and you are not to use this equation. So that is my big warning. If I could if I could make bells and whistles ring right now, I would. All right, so what are the types of dilutions? This one is called a serial dilution. At the top, I've shown you M1V1 equals M2V2, and then I've kind of rearranged it to get to what you see on the bottom right, which is M1 times V1 over V2 equals M2. All I've done is divide both sides by V2. And what that does is that gives us what's called a dilution factor, that V1 over V2, meaning how much did I dilute my compound. So what you see in this picture is a dark purple solution, and all we're doing is we're diluting it. And how we diluted it in this picture is going to be from one compound to the next and so on in what's called a serial dilution. And you'll see what I mean by that in a second. But let's work from the first stock solution to the next flask that you see here. These are Erlenmeyer flasks. The way they work is you put a compound in it, and then if you dilute to that line that you see here, to that meniscus, then that total volume is 100 milliliters. And these flasks are fantastic because volumes are not additive, meaning if you add 99 milliliters of one compound and one of another, if they have a different density, that kind of thing, their total volumes are not going to be the same. If they're both made out of water, the volumes are pretty well similar. But with flasks, they allow you to mix different compounds that might have different densities. But the important part of this is by using a flask, it makes it so your total volume is known. And so for all of these examples, the total volume is 100 milliliters. And so you place your sample in the flask and then you dilute it. And so knowing that final volume is important. So for this first stock solution, how we're going to dilute it is we're going to take 10 milliliters out of that stock solution and we're going to place it in this next flask that you see here. That's just a little bit lighter of a purple. And then we're going to dilute it to 100 milliliters. And so that's what you can see here, that as you add more water to it, it's becoming a lighter shade of purple. And so how much did we dilute it? We diluted it 1 to 10 because 10 milliliters was diluted to 100 milliliters. So that dilution factor is 1 to 10. So what that tells us is when we put it in the M1 V1 over V2 equals M2 equation, we've got 5 times our 10, which is the number of milliliters of our stock, over 100 milliliters, which is our total volume, equals 0.5. So we're going to call this solution A. And we can further dilute solution A by taking some of it out and diluting it with water once again. And so now maybe we took 10 milliliters of A and diluted it to 100 milliliters. That's still a 1 to 10 ratio. It's just we started out with a different initial molarity. That being what was the molarity of solution A. And so you can see in our equation here how that changes what our final math is, so that now we figure out the solution B maybe has a molarity of 0.05 molar. And then we can do that again, where we take from B to C, and we're going to take 10 milliliters of B, dilute it to 100. You can see how it's getting even lighter pink. Still a 1 to 10 dilution ratio. And when you put the math into the M1V1 equation, it makes it so you start out with a new molarity, that of solution B, times the volume of B, divided by your total volume. And so that's what you see here in order to get our molarity of solution C. The important thing here is that with this type of serial dilution, you're going from one flask to the next, and then from that new flask to the next flasks, and then from that new flask to another flask. And so it's a serial dilution because you're going from one all the way to the other. That's going to be different than just dilution from a single stock solution. We could also do the same type of math, but instead of diluting it from one to another and then keep on going from that new creation, you can go back into that stock solution every time. What do I mean by that? Let's try and see. This one starts out the same as before, where we place 10 milliliters of a stock solution and we're diluting it into 100 milliliters. So it's still a 1 to 10 dilution, and our solution A is still going to have 0.5 molar concentration. But now, instead of going into solution A and pulling from A into B, we can pull from the stock and dilute it. Now, if we pulled 10 milliliters and diluted it to 100, it would be that same purple that you see of solution A. Instead, we need to pull a smaller volume to make it more dilute. So in this example, I'm just pretending and saying that I pulled 1 milliliter of the stock out and diluted it to 100. So now my dilution ratio is 1 to 100. And so when I put that math in, notice how this changed from the previous slide. My molarity that I started out with, my M1, is 5 because my molarity of the sample I pulled out of it came from the stock. And so I pulled 1 milliliter of the stock out and diluted it to 100. So see how else that changes it. My V1 now is no longer 10. It's how much of my stock did I pull out. I pulled out 1 milliliter and then I diluted that to 100. So I still end up with the same concentration. It's just how I got there is different because what I did in the lab was different. And then we can do the same thing for this third solution where I pull from my stock solution and I dilute it. If I want it to be even more dilute, as you can see by the lighter purple color, I need to pull a smaller amount out. So in this case, I'm going to pull out 0.10 milliliters out and dilute that to 100. That's going to be a 1 to 1,000 dilution ratio. And now notice how my M1 times V1 over V2 equation changes. And so there's my molarity of solution C. But each time I'm just asking the question, what was the initial molarity of the sample I pulled from? How much did I pull from? And then you divide that by your total volume to give you your new molarity. We can do this in Excel, and so let me open up Excel and show you how you might do this in Excel. All right, here is Excel, and I have set it up so that we've got serial dilution equations are on the left, and then dilution from a single stock solution are on your right. And so what we start out with in a serial dilution, remember this is where you go from one stock to the next, to the next, to the next. And so that's a serial pattern. We still need to ask the same questions. What is my M1? My M1, remember, was that 5 molar. My V1, how much did I take out? I took out 10. What was my final molarity? I don't know yet. That's what I'm trying to solve. What's my volume? My final volume was 100. Okay, and in each of these cases, I pulled out 10 of the previous, and my final volume was 100. So I can hover over, get that dark X, and drag it down. My M1, what is my M1 for this next row? My M1 for the next row equals whatever my M2 was previously. So I can just do that, and then I can drag it down. Because when I drag it down, this is going to make it so that this concentration is whatever this was previously. All right, but what about M2? So I'm trying to show you how to automate this so you don't have to type so much. So with M2, remember the equation was equals M1 times V1 divided by my V2. And that gives me my molarity. And then I can drag this down and I'm automatically going to have all of my values that you see here. Okay, including an extra one, which I accidentally did 3 dilutions instead of just the 4 flasks that you see here. So if I had done one more, I would have gotten this value here. So I'm going to go ahead and delete that just so I don't confuse you. So I can see in my picture that all of my M2s, my molarities, this would be flask A, B, and C. So I'll go ahead and label that. Flask A, flask B, and flask C. All right, so that's how you would do it if you have a serial dilution. Let me go ahead and show you those equations that you saw a second ago. So remember, we've got the initial molarity, we've got the M1V1 equation, and then each new molarity was based on a previous calculation. All right, but what about dilution from a single stock solution? So the difference between these two equations is it's still going to have this point, this equation is still going to be the same, but my new molarity is 5 for every single case. So I'm going to copy that over, and then I'm going to make the changes here in a second. All right, I've copied them over. For the first example, it was definitely 10 each time and the total volume was 100. All of the total volumes are still 100. But what changes is not the molarity. The molarity stays at 5 each time. But this is what changes. It goes from 10 the first time, 1 the second time, and 0.1 the third time. And so now when I drag my molarity down, you'll see the equation still works. It's just that now it's using these 5 molar for the stock solution and the new V1 that we used whenever we placed each of the stock solution additions into the flasks. And so that's just an example of how you would do the math for dilution from a single stock solution. Let me show you what those formulas look like now. Here are the equations for dilution from a single stock flask. So what's important whenever you're doing these dilution equations is figuring out which type of dilution you're coming from. Are you doing serial dilution? Or are you doing dilution from a single stock solution? Either way, you're still going to use the same M1V1 equals M2V2 equation. It's just that whatever your initial molarity is the initial molarity of whatever the solution is that you placed into your final reaction flask, or dilution flask in this case. All right, if you keep that in mind, I think you'll be good. You'll do the math appropriately. Just remember V2 is your final volume. V1 is the amount of the initial chemical that you placed into your final flask.